So, okay, Mukti, welcome on your media platform, and let's start your snap mock for power plant. And as you mentioned, you are preparing for CSL. When is your interview, Mukti?
Sir, on 17 February.
17 February, you are having your interview.
Yes.
So, what you prepared in power plant?
Yes, sir. Steam power plant, then a- uh, gas, turbine, power plant, and hydraulic power plant, sir.
So, Mukti, can you tell us, like, can you tell me, like, how you are going to choose a particular power plant? Like, suppose you want to meet some kind of load requirement of any particular area. So, on what
Okay.
basis you are going to choose a power plant? Like, you are having multiple options: steam power plant, solar power plant, gas turbine power plant, hydro power plant. So, on what basis you are going to choose the power plant? Just give me some kind of basic idea.
Sir, first, your criteria will be load your type, like for large power plant, like a base load is used. Then for short time and high load means for peak load, sir, like gas, turbine, power plant will be used. Then diesel, power plant, sir. And the next criteria can be the type of load, the type of plant capacity, sir. High
So, okay,
capacity or low capacity.
Mukti, what is the difference between peak load and base load power plant? How you are going to differentiate between peak load and base load power plant?
Yes, sir, means base load is the load which is always in means from start to the end, the load which is always is present in the power plant is known as base load. And for base load power plant, we use thermal power plant or nuclear power plant. And then for peak load is the load which is the maximum load that occurs for a short duration of time. And for that, since it occurs for a very short uh, duration of time, we need to immediately use the load. So for that, easy start stop is the main factor. So for that, gas, turbine or diesel or power plant is used.
Okay, what is work ratio? What is work ratio of a power plant?
Sir, work ratio means ratio between the net work output to the positive work output. And sir, one more is their back work ratio, sir.
So, what do you think? Which plant, like out of, if you compare steam power plant and gas turbine power plant, what do you feel? Which one is having more work ratio, and why?
Sir, for more work ratio, interview. Sir, for maximum work ratio, I think that in the case of steam power plant, since pump is used as the fluid is in liquid, so the pump work is less as compared to the gas power plant where the fluid is in a gas. So compressor is used, hence the work input for the compressor is more. So sir, I think that work ratio will be more for steam power plant, as the network value will be higher for the steam power plant.
Mukti, you heard about reheating. So what is the advantage of carrying out reheating in steam turbine power plant? Why we carry out reheating? What are the advantage of carrying out reheating?
So the main advantage is that work output from the turbine increases, and also simultaneously the efficiency of the overall Rankine cycle will also increase. And so in addition to that, secondly, higher quality of steam we get as output. So higher air quality means the dryness fraction of the steam will be more.
Mukti, sometimes we use regeneration also. Some part of steam we extract out of the turbine, we mix it with
Yes,
the
sir.
feed water. Okay,
Yes, sir.
just to raise the mean temperature of heat addition.
Yes, sir.
So Mukti, suppose the steam which is coming out from the condenser, if you will directly supply that steam into the boiler without
Sir,
passing.
please repeat again.
Yes, Mukti, is it possible in a thermal power plant to directly supply the steam which is coming out from a turbine into the boiler without rejecting the heat in condenser?
Sir, I think it will not be possible, since first of all, as the input for the boiler is liquid water and not mixture of wet vapor and water, means wet steam. And sir, in addition to that, for input to the boiler, we use cold feed water, and since steam has very high thermal energy, so sir, the overall cycle will not work. Means first we have to reject it, and then cool the water, and from their through feed pump, cold water is fed into the boiler.
Okay, Mukti, what is critical point of water, and how you are going to define the critical point? What do you understand by critical point?
Sir, critical point is the point where liquid water directly vaporizes to vapor. And sir, in case of water, the critical point is, I think so, 100 degree Celsius at 221 bar of pressure. I think so, sir. I am not sure about the
221 bar is fine, like 221 atmospheric actually. That is fine. That is right actually for the critical pressure, but critical temperature is not 100.
Not 100.
Okay, Mukti, sometimes we use some kind of supercritical boiler also. So what are the advantages of supercritical boiler over high pressure boiler?
Sir, main advantage is that since the inlet pressure to the turbine is fixed, so the blade of the turbine has fixed metallurgical property, and we can't change the blade. So sir, in critical cycle, what is done is that the liquid from liquid, direct vapor is formed, and the whole process of heat addition take place in vapor state only, not some portion in with steam and some portion in vapor phase. Whole heat addition take place in vapor state only.
You heard about deaerator, Mukti? Deaerator.
Deaerator. Yes, sir.
So where we attach deaerator and what is the function of deaerator?
Yes, sir. Deaerator is mainly used to remove the dissolved gases before the feed water goes to the boiler through the feed pump. And sir, the deaerator is attached between the feed pump and the condenser, sir.
So can you tell me some of the assumptions of Brayton cycle?
Brayton cycle. Okay, sir. CP is assumed to be constant for the ideal Brayton cycle. AR is assumed to be the working fluid. No leakages take place to the whole system, means for compressor, then furnace, then the turbine, and if it is a closed, then intercooler, no leakage from the atmosphere take place. And sir, thirdly, the whole compression and expansion in the compressor and the turbine is the reversible adiabatic or isentropic process.
So what do you feel? The Brayton cycle is a kind of reversible cycle?
Yes, sir. In ideal case, for our calculation, we take it as reversible, but in actual condition, it is not, since means air flow and some leakages take place, and also
if you will consider ideal Brayton cycle.
Okay, sir.
And ideal Carnot cycle, if you will consider, if both are operating between same kind of temperature limits, so what do you feel? Both will have same efficiency or different efficiencies?
Yes, sir. I think that the Carnot will have more, since Carnot is the cycle that is a completely reversible and has highest amount of efficiency.
So Brayton cycle is not completely reversible.
Brayton cycle is actually I am not sure, but I think that no, the actual Brayton is not completely reversible, sir.
Mukti, what do you feel? Which one is more economical, like the steam power plant or gas turbine power plant? Like in which case the power generation cost is less?
Power generation cost. Yes, yes, sir. Since most of the India has thermal power plant, based on steam. So, sir, I think that for practically the cost is less in steam power plant cycles.
Okay. So my last question is to you, Mukti. What do you feel like? What is the percentage share of thermal power plant in the entire electricity requirement or energy requirement in India? Present share.
Uh, 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 Means yeah, like 45 to we are 48, and yeah, means yeah, this share is gradually lowering, yeah, due to the setting up of solar power plant and all other renewable forms of energy, sir.
Okay. Mukti, my last question only. Can you draw the Rankine cycle with the reheating?
Reheating.
And Mukti, tell me this also. What do you feel? What is the effect of reheating on efficiency of a thermal power plant?
Sir, in case of reheating, the efficiency may increase or yeah, decrease since the yeah, turbine work output actually increases, but at the same time, heat heat input also means means increases. So I feel that efficiency may increase or yeah, decrease, sir.
ठीक है मुक्ति. Yes, Mukti, done.
Straight lines are here. Means straight line, since the expansion is this will be, sir, reversible adiabatic or
So turbine, there is only one turbine or two turbines?
low pressure and one high
pressure. So the turbine which you have shown, that is high pressure or low pressure?
Low pressure, sir.
Low pressure.
First high pressure, then reheater, then low pressure, then this economizer, air preheater, electrostatic, this electrostatic means electrostatic
precipitator.
Yes, sir. And then I think fans come like
ID fans.
Induced draft fans, sir.
ठीक है Mukti. I think now I can provide you the feedback. So Mukti, technical knowledge wise it is looking fine because most of the question you answered and very correctly on the right line you answered most of the question. So there is no such problem with your technical knowledge, technical content. And yes, I feel you face some kind of difficulty in speaking, but that reflection also I'm getting very clearly and very strongly. Yes, you're working on that
Yes, sir.
speaking. Okay, because
Flow
when you
of
are
words is
yes,
slow.
yes, you are trying to speak up slowly. Okay, and you are taking
Yes.
sufficient time. That's why it is looking nice. There is no such problem. The interviewer will be easily able to understand what you want to say. Okay, and it is good actually if you're facing some difficulty in speaking, then it is good to speak up slowly, so that at least it will be very clear to the interviewer. Okay, so okay, your approach is fine, and it is on the right line. So एक दो points है, let me discuss those points with you. Like I initially asked you about peak load, base load plant, what is the difference? So that point was right. On what basis we identify a peak load and base load plant, and how we are going to choose a plant? It depends on many factors. So first, it depends on the load, it depends on the availability. Okay, what type of the resources available to you. Like if you are having a huge kind of water available, then obviously it will be easy to install
hydroelectric power plant or steam power plant.
Steam power plant, you can go, like if you are having abundance of coal available, space also is another criteria. So it depends on so many factors, but the point is, like the point which you highlighted, those are right. एक दो points आपने जो highlight किया, I'm satisfied with that. Work ratio also you answered. I asked you about the then is it possible to remove the condenser? That also you answered. That is actually a violation of second law of thermodynamics. It is not possible to convert heat into work without actually rejecting heat to the atmosphere. So it is not possible to develop any kind of cyclic heat engine which is producing work continuously while exchanging heat with a single reservoir. So what do you need to say, sir? If you will remove the condenser, then at the exit of the turbine, the pressure will also be very high, because with the condenser we are maintaining the low pressure at the exit of the turbine. Because when you are carrying out the condensation of steam in water, there is a huge pressure drop, and due to that pressure difference in the turbine, we are getting the work output. So if there is no such condenser, there will be no such drop in pressure in the turbine, and in that case, we will not have any kind of work output. Okay. So practically also the work output will be zero, and theoretically also it is actually a violation of second law of thermodynamics. Okay. And then if you want to circulate steam, then you require some kind of a compressor.
Yes.
With pump, you will not be able to supply the steam into the boiler.
Yes.
So, the small part of work which you are going to get in that turbine, you need to supply the even more than that into the compressor to circulate that steam into the boiler. So overall, net, or what you can say, finally, you are not going to get any kind of work output. Okay. So practically also you can justify, and theoretically also through second law of thermodynamics you can justify that. Critical point of water is 374 degrees Celsius. It is close to 373.96, something like that. 374, roughly it is 374 degrees Celsius. And the critical pressure you highlighted fine, 221 atmospheric, or close to 22.06 megapascal. Brayton cycle is only an internally reversible cycle. It is not completely reversible. Carnot cycle is both internally as well as externally reversible. Okay. Brayton cycle is only internally reversible because the processes are frictionless. Okay, there is no such kind of losses inside. But when you are adding heat, when you are rejecting it, you are adding and rejecting it with finite temperature difference. The heat addition is not at constant temperature, and rejection is also not at constant temperature. So it is not completely reversible. For that point, okay, that's why even if Carnot and Brayton both are operating between same temperature limit, the efficiency of Carnot will be highest because it is a completely reversible cycle, and its efficiency depends on the temperature limit only. But that is not the case for Brayton cycle. Okay. So strongly and very confidently, very clearly, you can say that the Brayton cycle is not a reversible cycle. It is only internally reversible, partially reversible. What you can say. DRDO ठीक था आपका, efficiency point आपका ठीक था. With the reheating efficiency, we cannot say it is going to increase. It depend on the reheat pressure. At what pressure you are carrying out the reheating. तो ठीक है, मेरे ख्याल से मुक्ति, most of the answers were right. तो ठीक है, अभी मेहनत कर दे रहो. I think if you will work on your slightly
speech, sir. Speech is the main problem for me.
Yes. I think then it will be much better, more good. But this time also it's fine. Okay.
Yes, sir.